So we hear the ARM TechCon, and who are you?
Hi, I'm Nathan Brookwood. I'm the research fellow at Insight 64. I've been following microprocessors and systems on chip for 20 years now. And for the last 5 years, I've been watching what's going on with ARM and its 64-bit efforts. It was just 4 years ago that ARM came to this conference and started talking about what they call their V8A, or 64-bit architecture. And during those 4 years, it's gone from being sort of something on paper with one or two early trial implementations to a place now where you can buy 64-bit ARM chips for servers from several vendors. And in fact, ARM this week said that they plan to ship 50% of the chips in smartphones based on 64-bit capabilities this calendar year.
So this calendar, that's like, there's only a month left.
There's only a month left.
Basically, they're saying right now it's 50%
they're
already.
They're saying that for 2015, half of their smartphone shipments will be 64-bit capable, which is really a staggering number, isn't it?
It's huge. That means everybody's buying 64-bit already. I mean, 50% are.
50%. Now, one of the things that helps, especially in the smartphone segment, is that Apple, who officially has never been acknowledged as an ARM customer, has, for the last 2 years, been shipping only 64-bit versions of its iPhones and iPads. And Apple accounts for somewhere between 25 and 30% of all the smartphone units on a worldwide basis. And so that gives them a big boost in terms of meeting that 50% number. But then with the other ARM partners, Qualcomm, Hisense, and all of the broad array, they've all introduced 64-bit versions of Big.LITTLE this year. And so that gets them to 50%. It's amazing.
And actually, the Big.LITTle is really successful. I mean, right now, everybody's doing Big.LITTle. Qualcomm is doing a Big.LITTle, MediaTek. And so that means it's stable, it's working.
Oh, Big.LITTle's been working for a couple of years. When it first came out, it was somewhat constrained in terms of what it could do. And in fact, I remember when they first talked about it, basically you either had the big processors running or the little processors running, and you switched back and forth depending on how busy the system was. But they've evolved that over the years, so now you can have a mixture of big and little processors running. And as they're moving forward, they're even going to figure out on the fly whether particular tasks are better suited for the big or the little processor, and make sure that they get mapped onto an appropriate core when they're executing, so that you'll have a big mix or a mix of big and little cores based on the workload. And that makes the whole idea a lot more sensible than only using half of the processor resources at any given time.
So everybody, like all the new Sony, the new HTC, every big high-end phone is using 64-bit, and even lots of low-end, like the MediaTeks, they're doing lots of LTE 64-bit. So your website, your company is 64. Why is it 64?
When I started Insight 64 18 years ago, the 64-bit transition had already occurred in proprietary servers, but x86-based servers and Windows PCs and Macintoshes were all still using 32-bit chips. And I carved out this little niche of looking at the 64-bit transition as it was going to play out over the coming decade. And in fact, it worked out pretty much the way I had expected, at least in terms of PCs. where the driving force for the move to 64 bits turned out to be when people could configure systems with more than 4 gigabytes of memory. And that's because, from an architectural standpoint, if you want to use more than 4 gig of memory, you really need a 64-bit processor. And back then, back in 1998, typical systems were going out the door with 512 megabytes of memory, and nobody cared about 64 bits. Whereas some big iron servers were going out with 2, 4, and occasionally 8 gigabytes, and that drove the server community to adopt 64 bits much earlier than the desktop and notebook arrangements. But memory gets cheaper all the time. You know, we talk about Moore's Law making processors faster, but it also makes memory cheaper. And people, as the memory costs come down, put more of it in a system. My hypothesis back in 1998 was when we get to 4 gig, then people are going to want 64-bit chips. And in fact, if you plot the adoption of 64-bit technology in the PC space and even in the Intel server space, you can see exactly where those 4 gigabyte boundaries crossed and where people started to then generate systems using 64-bit chips instead of 32. And of course now we've passed that. Even an inexpensive PC comes with 4 gigabytes of memory. And so every PC, I dare you to find a PC on the commercial market now that doesn't have a 64-bit version of Windows. It took a long time, but we got there. Now, as a matter of fact, after that happened, people would come to me and say, Nathan, you're going to have to become Insight 128 because 64 bits is kind of old hat. Fortunately, the folks at ARM came along and said, guess what? We're going to do 64-bit chips for ARM products. And all of a sudden, people got interested in 64 bits. They got even more interested when 2 years ago, Apple introduced the first iPhones, I think it was the iPhone 5, with 64-bit capabilities and an iPad with 64-bit capabilities. And suddenly, everybody needed a 64-bit chip. And that has driven the adoption of 64-bit across the industry and led to this new statistic that ARM just dropped on us yesterday. 50% of all the smartphones are going to be 64-bit capable by the end of the year. Now, some of the people buy those chips and still put the older operating systems, the old versions of Android on them with only 32-bit capabilities. But many, especially after Lollipop came along and had support for 64-bit features built in, that kind of served as a trigger for the Android world moving to 64-bit capabilities.
But so even the smartphones, like it's already 50%, but none of the smartphones have 4 gigabyte of RAM. Very few.
That's right.
So that means when there's 4 gigabytes, maybe next year, or they'll accelerate even more, or are there other
There
things
are other
that are
reasons. As a matter of
useful?
fact, again, my hypothesis, especially with the PC transition, was you need 60. As soon as you're going to need 64 bits to deal with 4 gig. But it turns out ARM made a number of important changes to the architecture when they went from version 7, ARM v7a officially, to version 8. They really cleaned up a number of things that had been problematic with the 32-bit configurations. And they also added new features, especially for handling data encryption features, which have become increasingly important as people start worrying about their systems getting hacked. And so the ability to do encoding and decoding of data on the fly without dramatic CPU overhead has made the V8 architecture interesting even to people who don't have 2 or 4 gigabytes of memory, where the 64 bits would be mandatory. We do see some high-end Android phones that now are coming out with 4 gig, where it makes sense to take advantage of the addressing features. But the other features in V8A made it attractive even before we had the memory pressure for 64 bits.
Do you think ARM did a better 64-bit design than Intel?
That's a tricky question.
Intel kind of just had to kind of like follow what AMD was doing, no?
Well, of course, as a matter of fact, Intel exactly followed what AMD was doing. Because prior to Intel doing the 64-bit version of x86, Intel was trying to drive the industry to a proprietary industry 64-bit standard known as Itanium. And Intel had felt like, hey, they let everybody and his brother build 32-bit x86 chips, and they thought that they would have more intellectual property protections if they had a unique 64-bit instruction set. So they came up with Itanium. It was a very complicated architecture, and while it made some sense to do that for high-end servers, they couldn't really drive mass adoption. And AMD came along and said, there's a much easier way to get to 64-bit capability than converting all your software to Itanium, and it's called AMD 64. They started to get a lot of traction with that even before there was any 64-bit software for either AMD or Intel. But people said, yeah, that looks easy. We like easy. And that compelled Intel to add 64-bit features to their in-development Pentium 4 and beyond processors. That's all been laid out very clearly by some of the Intel insiders who have since spoken about that time at Intel. It's really quite exciting because I could only conjecture what was going on, and these guys then started talking about it, and it turned out the conjectures were reasonably accurate. But the bottom line here is Intel made a very sensible decision rather than trying to split the industry with 2 different 64-bit x86 standards, to go with a consistent one. And since AMD had gotten there first, they just had to copy them. It's probably one of the few times in the history of the competition between those 2 companies where Intel copied AMD. And even when they were doing it, or when they finally did announce it, of course, they didn't say they had copied AMD. What they said is they had designed their extensions so they would run the same software that was being adapted for the AMD 64-bit products.
So Intel is running AMD 64.
That's right. If you go and you look inside any of the Microsoft Windows sources, each module has an identifier which talks about the various configurations it supports. And there's one for x86, and then there's one that says AMD 64. And that's the one that you use when you want to generate code for
Intel 64.
For Intel 64.
So ARM did it differently. They kind of like redid the whole architecture, kind of, right?
Well,
so there's like more innovation happening on this 64 jump.
ARM definitely saw this, when they were moving to 64 bits, that there was room for more registers, that there was room to clean up a number of areas where the 32-bit version architecture was constrained. And, of course, then they added these other features for data encryption and so forth, so that all in all, you got the 64-bit addressing and a number of other goodies, because computer architects who love to be able to enhance their instruction sets know that it's very hard to persuade software developers to recompile their code to take advantage of a new software instruction. So they only do it when there's some really big benefit or when the industry is transitioning. So there was a massive program throughout the entire software industry to recompile code for the 64-bit x86, and that's when everybody went off and took advantage of these things. ARM saw the same kind of opportunity, knowing that people who are distributing software that's based on ARM are not going to rewrite that or recompile and translate that software willy-nilly. So they took the opportunity to throw a number of new features into the 64-bit version. And it made it so that even if you didn't need more memory, you still got a roughly 10% performance advantage using the 64-bit version of the chip, even with the same physical memory and the same semiconductor process technology as you used with the 32-bit versions of the ARM architecture. So there's motivation to do that. But clearly, once Apple said, hey, look, iPhone 5, 64 bits, everybody then needed to get on that bandwagon, and all hell broke loose in terms of companies that had not been thinking of 64 bits as being a necessity. Suddenly, all of a sudden, they started to see it that way. It was amazing the way that transition happened in terms of people's perceptions. It took a little longer for people to actually evolve the products, but by early 2015, we started to see those products in the market based on the various 64-bit cores, the oh my goodness, the A53 and A57s in particular that ARM had developed. And some people who had gotten a head start on doing that, obviously Apple was one, had their 64-bit parts in the market sooner. And now we're seeing almost everybody come out with 64 bits. And now that 64-bit capability is super important for ARM's penetration of the server market. Everybody's talked about ARM servers for a long time, but most people who had tried to do ARM servers based on the 32-bit architecture were unsuccessful. Some of them, one of the early pioneers, Calzada, actually went out of business trying to persuade people to do that. But now we've got 64-bit ARM chips. We've got a lot of 64-bit operating system support for server applications, all the important versions of Linux, Ubuntu, Canonical, Red Hat, and so forth, all are available in 64-bit versions for ARM. And a lot of the middleware that you would need to create a server for ARM, 64-bit ARM, is also now available. And ARM's done a lot working with ISVs, in particular through its Linaro affiliation, which was formed specifically to get people were thinking about ARM for servers and 64 bits. So all of that's coming together, and the result is that in 2015, we've begun to see some critical mass, chips, systems, operating systems, middleware, all available, and finally, not only available, but you can, call up Hewlett-Packard or Supermicro, people like that, Gigabyte, and buy the motherboards and the components or the systems that you need to do that. And as a result, especially I think Hewlett-Packard, who's been very aggressive with its Moonshot program, offering server blades based on the 64-bit ARM technology from Applied Micro. That has been that's being used both in TSMC's own internal IT applications and also in ARM's own announcement or use applications. Matter of fact, that was another big announcement here today, that ARM has moved its ARM.com hardware infrastructure from x86 to ARM. So now when you go to the ARM website and look up product specs or whatever, that's all being handled by an HP Moonshot configuration populated with ARM blades as opposed to racks of Intel x86-based servers. That's new this week.
I'd like to have my ARM devices.net run on ARM too. Hopefully I can find some kind of host somewhere that can like guarantee that it's hosted on ARM or something.
Well, right now, most of the applications or most of the sites that are using ARM, the use of ARM is very transparent. You can't tell whether it's ARM or Intel. And I think ARM would just as soon have it that way. As a matter of fact, they like to describe it as boring.
Yeah.
That, you can take all of your applications, get the ARM versions of the code as opposed to the Intel versions, run it on the ARM adapted version of Red Hat or Ubuntu. And if you're the IT guy, it will look just the same and you'll support it with the same kind of tools as you would with an x86.
But you would save a lot of money on power, on the cost of the hardware, maybe. I mean, that's the promise, right?
The marketing proposition for ARM-based servers is that you can get a lot more servers into the same power envelope as you would when you're constrained by x86. So if you want to spend $50,000 on servers to do something, you can get more ARM servers for $50,000 than you can get Intel servers, and you'll be able to fit them into the same 15 kilowatt kind of power envelope per rack that you would need if you were going to be using Intel-based chips. So you get some improved density, more processors doing more work for the same ultimate acquisition cost. That's sort of the proposition as it's evolving now.
But if it really turns out to be true, then that could be an issue for Intel, right? And ARM says they believe it's going to be 25%.
ARM put a stake in the ground this week. This is another one of the newsy kind of things that's come out of this conference, saying that their internal projections are that they will be able to capture 25% of the server market by 2020. Now, that's 5 years out. And I can envision, they've probably just gone through a 5-year planning process inside ARM. And they, in the course of doing that, they looked at what was going on competitively. They looked at who their partners were and how their partners are doing. And they put that stake in the ground. So it's 5 years off. 5-year projections are interesting. And somewhat measurable. It's not like it's 10 years or 20 years out. So we'll know in a couple of years how they're doing on that. But to me, it seems like it's an aggressive but achievable goal. And the reason I believe that it's achievable is that there are a lot of as the server market has evolved over the past 5 or 6 years, we're seeing a lot of transitions from the traditional kind of server deployments inside enterprises where a company would go out and buy 100 servers and throw them in a data center somewhere and have a small IT staff administering those servers and making sure that the software worked and all of that. These days, those kind of companies are outsourcing those workloads to the web, to the cloud. Excuse me, wrong word. Yeah. Cloud's an important word. And once it's no longer in your own data center, but it's in the cloud, then there's a lot of flexibility that the cloud provider has in terms of how they actually deliver those services. Some of that work, especially if you're, let's say, taking virtual machines that were running on Intel machines in your own shop and moving them to Amazon Web Services, those are very much bound to x86 because a virtual machine still needs to run on real hardware, and so the x86 instructions matter. But a lot of the workloads, if you look at what's happening with people who are using Salesforce or other software as a service kind of applications, they don't even know what the hardware is or what the instruction set is. And that gives those cloud vendors the ability to change the underlying hardware architecture and still deliver the service. So the cloud guys, who are obviously very motivated by how much does it cost me to buy this hardware, how much does it cost me to run that hardware, because that's my business. If I can get more bang for the buck or do more with less power, because power is a big part of the equation, that's a big win for them. So if ARM comes along and says, hey, look at how we can populate that rack with ARM-based servers, and you can do a lot more, and it won't cost you any more to buy it, but you'll save 20% or 30% on electricity, that's a big win for those guys. And I think we'll see that increasingly over the next couple of years. It's even a bigger win for a company like Google or Facebook, who has control of their entire software environment, operating systems, middleware, applications, that's all written and maintained by developers at Google or Facebook. Nobody cares what it really runs on. And so if you come to those people and say, look at how we can do a lot more work, and all you have to do is jump through this small hoop of recompiling all your software for ARM to do that.
Those guys can jump very quickly to do that.
To adapt their software, which is today running on hundreds of thousands of Intel servers. They can start, as they refresh those data centers, those cloud data centers, they can refresh them with hundreds of thousands of ARM servers, use less power, they'll pay less for those ARM servers, and it's almost a no-brainer for them.
So Amazon acquired Annapurna, making ARM servers, and Baidu is experimenting, Alibaba. Is there any chance that maybe Google is already deploying massive amount of ARM servers, just not announcing it?
Well, you can never tell. And I have no special links into Google to be able to comment on that. But and one of the problems I think that ARM has is this trend. If this trend starts, most of the people who are doing it are not going to want ARM or their suppliers to talk about it because they think that they're being very clever by moving to ARM, and they don't want to have their competition think, oh, that's really a good idea. We should do that too. It's kind of funny. For example, today we had a press conference here with ARM, and we were talking about their 50% of mobile products being 64-bit. And I said, well, of course, you've got a head start because Apple is using 64-bit ARMs in all of their products. And the ARM executive says, we can't comment on who our customers are. And so even though everybody in the world knows that the Apple SoCs, the A6 and the A7 and the A8 and A8X and all, are based on ARM, ARM would not even acknowledge that in public. So you can imagine a company like Google getting their suppliers to swear to take a vow of silence about what they are supplying. So the challenge is, will people who are working around, trying to go through trash cans to see what's going on in these different companies, are they going to be able to ferret out that that latest data center deployed by Google is actually filled with ARM servers?
All right, and maybe that's why some people at Amazon were kind of like trash talking the ARM servers at one point. They probably don't want the competitors to know that they're making all the web services run on ARM very soon.
I think there's a lot of that goes on, a lot of miscues that people are communicating to try and confuse competitors. I think it's kind of silly because we all find out eventually what's going on, but nevertheless, it's part of the game that people won't talk about what they're doing strategically in many cases, and may even misrepresent what they're doing to confuse competitors.
And there was some kind of rumor coming out of Apple and Intel working together on something. Maybe the next iPhone 7 would be, Intel would try to work on that, but do you think it would be ARM-based if Intel makes it?
Well, I think Intel has always had a desire to serve as a foundry to ARM. At every iteration, there have been discussions. Of course, none of this is openly acknowledged, but again, industry rumors are that Intel and Apple have talked about Intel making Apple SoCs in an Intel factory. It would be a lovely piece of business if they could get it. I think they've had challenges agreeing on pricing. I know Brian Krasinich, the CEO of Intel, says they will make any chip for any company as long as Intel can make a return on the investment. And Apple, on the other hand, has the view that any supplier who Apple deigns to do business with should be willing to do it, even if it means losing money, because Apple is such a wonderful company.
Yeah, and they won't try to make money selling to other smaller
That's right.
companies.
So when you have Intel and Apple, Intel insisting on making a reasonable profit, Apple insisting on its suppliers selling to them at rock bottom prices, that sometimes makes for a very difficult negotiation, and so it's never worked out. Now, would Intel, could Intel persuade Apple to switch to some version of Atom for a future generation of iPhone or iPad? I would find that very hard to believe.
Very unlikely, no?
Very
There
unlikely.
has to be a lot of native code in all these iPhone apps, no?
Especially with iPhone apps. If you look at Android, just to contrast with iOS, with Android, once you've ported the Android operating system and some of the virtual machine software to Android, everything else runs in interpretive mode. I think it was called Dalvik code at one point. The latest iterations are ART, which is ARM real-time code. And so when you're a developer, you distribute code that's written in this intermediate language, and it gets bound to the hardware, i.e. translated to the instruction set, as the code is running every time you load the application. That's not the way Apple's iOS works. When a developer creates code for iOS for an application, they actually spit out code that knows exactly what the Apple ARM environment looks like. So if you wanted to switch to a different underlying hardware architecture, all those developers would have to change all of that code. That's sort of the way the Mac OS worked when you think about Apple moving from the PowerPC stuff that they had in the 90s to the x86 stuff that they adopted in the mid-2000s. All of Apple's software partners had to rewrite or recompile every application for x86. And software developers don't like to do that. And so that would be a big problem, I think, in any kind of potential transition from ARM to x86 for any kind of Apple iPhone, just as it would be a big transition if Apple said, hey, we're going to make a MacBook that uses an ARM chip instead of an Intel chip. All of those ISVs who have Mac software would have to rewrite that for the ARM stuff, and they wouldn't like that either. So these instruction sets, although they're very low level in terms of the overall software hierarchy, do play an important role in constraining where you can move software and how easy or how expensive it is to move software. And that's always been an issue for every platform in over time in the computer industry, which is one of the things that one of the things I like about ARM is if I'm a software developer and I've written software that runs, say, on the ARM 64-bit architecture, now I can move that to platforms based on Applied Micro ARMs or Broadcom ARMs or Cavium ARMs or AMD ARMs or Hisense ARMs, and the software will run the same in each environment. May run faster or slower, but it will run without needing to be tweaked. And that's just an incredible change in terms of the way competition will play out in this ARM-based segment of the server market. And I think that's going to be just huge.
Huge. Do you think maybe the 25% are underestimation?
Well, I think 25% is still very aggressive. But, and the 25% number, I think, presumes that they're going to get some of these large cloud suppliers. But once the market starts to mature and a lot of the so-called enterprise software that people would run on their own servers in their own data centers, once all that is mature, and so then if you're an IT manager, you can sort of call up HP and say, hey, I want this Intel Xeon-based server, or I want this ARM-based server, and HP configures the OS and all the middleware stuff, and you call up your application supplier and say, hey, I want this version, and they say, do you want the Intel version or the ARM version? Then you could start to see some penetration even in traditional markets. But I think that's going to be the last place where we'll see the ARM products start to move into the server segment.
They definitely can use more than 4 gigabyte RAM on the servers.
Oh, absolutely. If you couldn't support more than 4 gigabytes of RAM, don't even bother calling on them. And so the 64-bit technology was huge in terms of enabling the start of this ARM transition. And of course, servers have to be a little bit more hardened than convention and say mobile phones, because you've got a lot of people depending on that individual server. Maybe, only a few, 100 at a time, but you're constantly, those things are being banged on 24/7, whereas the chips in your smartphone are kind of loafing most of the time. And I'm sure, if you had a core that's been working in a smartphone running into a core that's been working in a server, and they meet in a bar and they start talking, the guy who's been working on the server goes, I never get a rest. It's just hour after hour, day after day. I'm always running at 70 or 80% of capacity. And the smartphone guy will go, what are you talking about? Life's a breeze. I can just,
I don't need
they
a
wake
fan.
me up every once in a while. I put something on the screen. I go back to sleep.
I'm
Why do you-
fanless. Fanless in the phone.
And I'm fan, yeah. So the CPUs in mobile devices, and even the CPUs in most PC devices, don't work very hard compared with the CPUs in servers.
All right, so it's gonna be fun. Future next few months, the next couple days of ARM TechCon. The ARM server space is there's lots of KVM. It's doing awesome stuff, and AMD and some other guys are coming into that space.
Hey, it's going to be fun, and I love it because I think that competition really benefits the entire market and end users. And in the past, the history of the computer industry is vendors would get a proprietary lock on a user because it was so hard to move software once the user started got involved with any particular architecture. This is the history of computer systems from the 1950s on. And what ARM does is they completely break that model. Basically, once you are using an ARM processor, you're not going to care whether the ARM processor comes from Qualcomm, Broadcom, AMD, or whatever. You'll care, but the software won't care. And just as in the brief period where AMD and Intel were going at each other in the server market, a customer could buy an AMD-based server or an Intel-based server, and nobody outside the data center even knew what was going on in that data center. The Intel sales guy and the AMD sales guy knew, but nobody else outside really cared. And that's because all the same software ran on both of those configurations pretty much interchangeably. And that's what we're going to see in spades as the ARM server market matures. Nobody's going to care what brand is on the chip. They're going to care about how fast it runs, how much power it consumes, maybe even the system supplier who put that system in place. But those are the kind of things that are easy for end users to determine and will make for a much more competitive market.